a whole bunch of emails, send her a whole bunch of emails, and see what gets through. And then we determine what works and fire it off to all of those employees who deserve it. And this email here is an example. It was actually sent to a Gmail account. And that's Outlook parsing it in the preview pane. So to the user, you don't see a whole lot of instances that this is Gmail. Like you just see help desk support, help desk at target company, please reset your password in one day. And this is an example of an email that got me domain admin. The actual admin put the link, put his password in. It was great. That was fun. They're always mad at you when you come on site. Because usually you do the phishing beforehand and we're like, oh man, put the link. Put in your password. It's not going to work. It didn't change either. That's the crazy thing. I told him when he did that, and he left it there, and then I came back and said, no. All right. So to phishing to execute code, I'm sure that's the right type. The click analysis. So we generally for Python, use Python to send the email and create a unique link per email link. So the first number in the list or whatever it might be, maybe an MD5 email. And then whoever clicks the link in access logs, we can see who actually, or whoever shows an access log, we can see who clicked the link. For doing credential grabbing, we may just use, like I said, a little PHP snippet. And for executing code, we're big fans of Empire. There's a lot of tools out there for generating payloads. So that's phishing. Any questions there? Leave it in the blog. You guys can check it out, read more. It works. Very, very successful. Moving into the web application realm, what we see here on the screen is what I like to do is a high level, just get an idea of how my input's being leveraged, and then to target that particular type of vulnerability. So you can see here, your input landing on the screen, for example, one of the first things we start to do is play around with XSS payloads. You can see, just go down the list, I'm not going to go word for word here, we'll try to walk through an example which is very near and dear to my heart because there's another way that I got domain admin from the internet, which is really cool. And that is a file inclusion vulnerability example. So with file inclusion vulnerabilities, describing the process of taking the file inclusion vulnerability to shell is a great way to pick up a girl or a guy at a bar. It actually probably would work with this crowd, right? I bet. It would impress me. But anyway, so file inclusion vulnerabilities are cool because the vulnerability scanner can tell you about them, but they aren't going to like massage it to a shell view necessarily. So it's nice to be able to like see this process. What I'm going to show is how an unlinked resource designed to debug pages on a web application led to domain compromise. And it was missed by automated tools, and I'll describe why as we go through it. But a little backup. I'm using PHP because that's the language I'm familiar with in my code. I'm not a developer, but I can put some code together. So file inclusion vulns, handling code execution, an example of that is leveraging like a PHP include statement versus a PHP echo. So it's just an example, like if your input's landing echo, it may just land on the screen versus PHP include, it may actually go execute this code. You have two types of file inclusion vulnerabilities, two high-level types: local file inclusion and remote file inclusion. We as attackers like remote file inclusion better. The local file inclusion is still fun. You generally just have to get your input into a file on a disk and include that file. It's generally referred to as log poisoning. R5 is a lot easier because you can just point it back to your server and run code. And in this example, I was on a pen test in a major, supposed to be a very secure environment, and I stumbled upon a resource called debug.php, and I put it in my browser, and it was just HTTP 200 OK. Let's do an unlinked content enumeration, which is basically figuring out what the web server doesn't necessarily tell you about in the links, but what it actually is on the server. And it was just a blank page, right? So nothing. Not a whole lot you can do here, just with the automated tools. They might find this, but it's just a blank page, right? So most people would give up and move on. I know I almost did. The next thing you want to do is figure out what are the inputs to this resource, right? So the web applications take input through parameters. So I went to lunch actually. I just never underestimate the power of a good lunch. I got some good spaghetti and syrup. Love syrup.
The spirit of the holiday season approaching.
So I went to lunch, came back, and I started to fuzz parameters, right? So I used burps intruder feature, and I basically just sent a bunch of requests to the web server with different parameters, as you can see in the URL bar there. And what I found was that page equals test gave back a larger response in my intruder window. So everything else was 193 bytes. The page equals test was 633, so check that out. And it turned out that I was getting a warning, a PHP warning. It said include test, right? So I'm getting really excited. I'm about to smash my keyboard now because I know that the input's landing in a PHP include function. I can potentially execute code. So the next phase is just to try to execute code. I did directory reversal on password, that worked cool. Now we point it back to my server. So in step one, I made the request here, just pointed it back to my attack box. Step two, I have a Python simulation DB listener, and I'm having it grab code for me, which is up at the top there, the system ID command. And step three, I'm getting it to run, which is great. It's a beautiful, this that feature. This feature was actually built to debug the page for the developer, but he left it on there on the internet, and I use it as well. And in this example, the real world example, was actually running a system on Windows box, which was epically awesome. As you might imagine, PHP running on Windows, you already know something's going to be kind of messed up there. When you're testing this, great. So another use of Python, just to automate all this is doing in the background, the screenshot is just automating web requests with Python request module that we saw in the previous slides, just Python doing step one, and taking your input on the command there and throwing it to the server and making it look and feel like a shell. You didn't put a file in the box, it's just automating the RFI process. And all right, this is Zach.
All right, thanks, Andrew. So I'm Zach once again, and this brings us to our third way that we exploit while we're on there. And this happens way more than you ever think it would, but multicast name resolution poisoning. Essentially what this is the majority of internal networks will, when DNS fails, or something is queried and it doesn't know the answer to the name, it'll basically have this name resolution traffic enabled for these various protocols. And you'll see this going on if you use a certain tool to get into that. But link local multicast name resolution. Whew, that's a mouthful. LLMNR, as Andrew has called Linder, which is totally wrong. NetBIOS name services, and multicast DNS. Essentially, these protocols, we can try and capture these protocols and manipulate them and even potentially crack them or get hashes or credentials. There's a lot of different things we can do, but by listening, intercepting, manipulating them, we can basically perform man-middle attacks with multicast resolution. So this enters responder. This is a great tool. It's open source. It's in Kali already by default, or you can just grab it off GitHub, but it's basically the Wreck-It Ralph of network pen tests. Essentially, enter responder. Responder is a Python script that you can use. It does this multicast protocol poisoning for those various protocols we mentioned. It also has other features and switches you can enable, like WPAD spoofing, which is essentially, let's say, and I'll get into this a little bit more, but with IE, it may have by default some kind of thing where it looks for a web proxy auto discovery feature, and when the user goes to the internet, it's going to try and make a connection. We have this WPAD spoofing on, it's going to look for a WPAD entry in the network, and we can essentially bring up a prompt or something to enter credentials, and boom, we got some scratch. But this tool is essentially a man-in-the-middle attack tool. It's going to try and intercept these credential exchanges, and we can eventually, after that, do some hash cracking. Maybe we can hack passes and hash, or we can do a relay attack. We'll get into that too. But it starts at a bunch of different services, as you can see here. It's a whole slew of different services, and we can go into our conf file and turn these on and off. But by default, it turns all these things on as rogue services. So here's our first use case. Essentially, we start responder, and we go against an interface. We do that dash I, or L, I can't remember off the top of my head. And then we do the dash F, which is fingerprint. And fingerprint is essentially going to try and grab as much information about this traffic as it sees it. So it's going to tell you, the versioning, the operating system, maybe, domain names, things of that nature. And it's going to also, as you can see down here at the bottom, it grabs an TLMP2 hash. So it is basically capturing these things as it's trying to authenticate across the network. Another use case is the WPAD one. So with this, you can essentially just add in a switch B for basic authentication and a switch W to enable the WPAD. And let's say someone's using IE, a certain version of that, and then they essentially are trying to go to the internet. Well, as soon as they go to the internet, the first thing they're going to see is this prompt. And they're going to go, Windows prompts me all the time to log into stuff, maybe not think about it. And they're just going to put their creds in. We just capture them. So that's another way you can use the network. Number 3, if you can't really do this active probing, it's not in the rules of engagement for your pen test, try to just do the switch A. And this is going to analyze the network and see if it even is possible. Are these protocols being used when DNS fails or when these queries happen across the network? It's a good way to just capture and show them maybe like, okay, you do have risk here. These protocols are enabled, you don't really need them. So how do we prevent this? So essentially, we're going to prevent this by disabling these protocols. They're helpful, they're useful, but they're not absolutely necessary. We can also prevent WPAD poisoning by entering a WPAD file entry in our DNS to point it and say this is where the WPAD is. So you don't need to broadcast out to the network, where is this WPAD file? And then we're the bad guy saying, I have a WPAD file, come to me, send me your friends. We can also segment the local network, just kind of like we said earlier. We don't want to have flat networks. We want to have these VLANs and things like that to try to prevent impact. stop the bleeding. And we also want to ensure that NTLM v2 is probably the weakest that we're using, or what we're using, and not allow downgrading to LAMPMAN or NTLM v1. So make sure you look at those configurations. And this brings us to our fourth example, where we can take what we just did here with the multicast name resolution glazing, and we can do SB relay attacks. So essentially, Edsco's put this very well, it's like the hash-to-hash of network authentication. So SB relay attacks occur when an attacker inserts himself between the NTLM challenge response authentication that we captured earlier with responder, and then essentially the attacker just needs to